Example 2.6. A molecule of a substance has a permanent electric dipole moment of magnitude 10 to the power minus 29 coulometer. A mole of this substance is polarized at low temperature by applying a strong electrostatic field of magnitude 10 to the power 6 volt per meter. The direction of field is suddenly changed by an angle of 60 degrees. Estimate the heat released by the substance in aligning its dipoles along the new direction of the field. For simplicity, assume 100% polarization of the sample. Okay. First, here, potential energy of the dipole. Formula for potential energy of the dipole is minus PE cos theta. What are the given values? Dipole moment is given as 10 to the power minus 29 coulometer. Then electric field is given as 10 to the power 6 volt per meter. The direction of field is suddenly changed by an angle 60 degree. What was the original direction? Original direction is with the field, that is theta equal to 0. And now it is changed to 60 degree. Even though it is not mentioned in the question, you should understand original value theta equal to 0. Now it has changed to theta equal to 60. Then how many moles taken? 1 mole. How many molecules are there in 1 mole? That is Avogadro number, right? So number of molecules in 1 mole, N equal to 6.022 into 10 to the power 23. Okay. Now, energy change for 1 mole. First, we'll consider 1 mole. Initial alignment UI minus PE cos 0. That is theta value is 0. So minus PE. Now, the direction has changed to 60 degree. Therefore, final energy is minus PE cos 60. Cos 60 value is half. So minus PE by 2. What is the change in the energy? Change in the energy delta U equal to U final. That is final energy minus initial energy. Minus PE by 2 minus of minus PE. This becomes plus PE. So change is PE by 2. Now we'll substitute delta U equal to half into P value 10 to the power minus 29 into E value 10 to the power 26. So if you simplify, you are getting 0.5 into 10 to the power minus 23 joule. Now the question is estimate the heat released by the substance in aligning its dipole for 1 mole. We can say this much heat is released. Energy is nothing but heat. This much heat is released for 1 molecule. How much for 1 mole? So, we'll go for 1 mole now. Total heat released equal to, this is for 1 molecule. So, heat released for 1 molecule multiplied by number of molecules. How many molecules? 6.022 10 to the power 23 into 0.5 into 10 to the power minus 23. If you simplify, you are getting nearly 3 joules of energy. 3 joules of energy is released for 1 mole of polarization.